Yes, we have seen how ethanol can be prepared in the lab by fermentation process. We have written the three equations with their respective enzymes and how the specific equation is brought about and the conditions which are required. Then after that we said when that ethanol is produced, it is impure, so we call it crude ethanol. And because of that, we need to offer another process called uh, fractional distillation. And the fractional distillation, we shall be in position to produce 95% pure ethanol, and then the 5% is water molecules. So now we are going to look at classes. Classes, if you don't want to say classes, you can say types of alcohols. Then after looking at the classes of alcohols with their examples, we shall be in position to distinguish between these classes so that when you're in the lab, you'll be in position to know that I'm dealing with this type of alcohol, this type of alcohol. So there are three types of alcohols, and one is what we call the primary alcohols. So primary alcohol examples are ethanol. We can have also butanol. We can have propanol and etc. So primary alcohols. Why do we call them primary alcohols? Because when we look at the arrangement of the carbon atoms, they are simply, you have just that straight chains. Take an example of ethanol, we shall have CH3, shall have CH2OH. So this straight chain tell us that we are dealing with what we call the primary alcohol. Now let's look at the second one, is what we call the secondary alcohol. Secondary alcohol. So secondary alcohols, we have what we call the butane to all. Butane to all. Then we can mean also to have propan to all. So here, the reason why we are calling them secondary alcohols is because when you look at their structure, and we say we have C, then we have another C here, we shall have another C. Then the branching is there. The OH is attached to this second carbon atom. So shall have something like this. Shall have something like this. So here I'll have hydrogen, I'll have hydrogen, have hydrogen, I'll have hydrogen. Here I'll have hydrogen, here I'll have hydrogen. So when I want to count this, I'll have 1, 2, 3, 4, 5, 6, 7, 8. So this tells us clearly 1, 2, 3, 4, 5, 6, 7, 8, 9 plus this. Then oxygen is here. So this is carbon 1, carbon 2, carbon 3. So when we are naming this, we can say propan, this one, propan 2. These positions is very important, propan 2 all. So the moment you see something like this, we are dealing with what we call the secondary alcohols. Now let's go to what we call the tertiary alcohol, which is now the last tertiary alcohols. So for tertiary alcohols, they have very many branches. You see that the best example we shall give here is 2-methyl propan to all. 2-methyl propan to all. So how can we write this one structural? We shall be in position to say we have 1, 2, 3. Then we have this branching OH. Then also there's what we call the CH3, which is the methyl group. We talk about this one. Talk about this in those hydrocarbons. Then here we shall be in position to have something like this. Have something like this. So this is what we call 2-methyl propane 2-ol. So here we shall be in position to see that primary alcohols, they have these straight chains. Here they have branching. Here there are many those other branches. They are the methyl group, the OH group. So these are the the three types of alcohols, and you'll be in position to at least know them with examples. Now, if we have known the types, then we shall be in position to distinguish. Shall be in position to distinguish. Uh, shall be in position to distinguish between them. So how can we distinguish? We can say there's a reagent, special reagents we use. The special reagent we use, and that reagent is called anhydrous. When I say anhydrous in chemistry, there is no water completely. Anhydrous zinc chloride and concentrated hydro hydrochloric acid. So this one here was designed by a guy called Lucas, and we call it Lucas reagent. So he mixed these two and he tried to test between the different types of alcohols, and he was getting different results. So it was named after him as the Lucas reagent. Now, what do we need to know here? What if I'm dealing with primary alcohol? Primary alcohols. What will I observe? Assuming this is my test tube. This is my test tube. I have inside here, example primary alcohol, we say ethanol. Say ethanol. And then now I have Lucas reagent. I have Lucas reagent. So I have to at least put some drops here. So here, what will I see when they react? What will I see? We call it the observation. So what will I see? So for primary alcohol, we shall be in position to say that with this one, no what? No observable chain. So that means you're not seeing any chain. What if I'm now dealing with what we call, if I'm to wrap this and say, I put what we call secondary alcohol here. I put secondary alcohol. Take an example, maybe I'm putting what we call propane 2-ol. Then I put the Lucas reagent. What will I see? So secondary alcohols, we shall be in position to see cloudy, write this one very well. Shall be in position to see cloudy solution. But this one, it is within 10 to 15 minutes. I mean, it is after 10 to 15 minutes. So that means when you're in the lab and you're checking for different types of alcohols, you'll be in position to at least wait for these minutes. You can continue with other works of yours, but you'll be checking after 10 to 15 minutes. Did you see any change? If it is not there at all, that means you are dealing with what we call the primary alcohols. If you have seen the cloudy solution being formed, After 10 to 15 minutes, then that means your conclusion will be in position to say, I'm dealing with what we call the secondary alcohols. What if now I remove this secondary alcohol and I place tertiary alcohol? I place tertiary alcohol. Then I lower this Lucas reagent, pour it there, drop by drop, or I just pour. What will I see if they react? So here we shall have tertiary alcohols. We shall see immediate cloudy solution. So that means if you are in the lab, you have to be keen enough. The moment you put this Lucas reagent immediately, an anhydrous zinc chloride and concentrated hydrochloric acid, if you have seen immediate cloudy solution, in your conclusion will be saying that I'm dealing with what we call the tertiary alcohols. What if I do not see immediate cloudy solution after that thing? What will happen? What will come into my mind is I'm either dealing with primary alcohols or secondary alcohols. But I need to first take time, around 10 to 15 minutes, and see whether it is secondary alcohols. If it is not secondary alcohols, that means you will conclude that you are dealing with primary alcohols. So that's the easiest way for you to distinguish between the different classes of alcohol.